Now, so far, we've been talking about risks for investments or for projects as kind of a binary. Either you double your money or you lose everything, or you get 30% or you get your principal back. But in reality, it's much more complicated than that. So this is where we're going to bring a concept to you called probability distributions. And if you think about it, it's more what happens in reality because you don't always necessarily lose all of your money or double it. There's a spectrum of different outcomes with any particular event. Again, let's just say you're making an investment in um, a new cancer center. I mean, it could be great, it could be okay, it could be mediocre, or it could be a total disaster. So you kind of have a spectrum of those possibilities, and that's called a probability distribution or the probability of occurrence, or we'll just say probability. Um, and the distribution is just a table format of all of those different outcomes that I've just said, whether it's going to be fantastic or whether it's going to be a total disaster. Now, in this case, we're on the bottom here, kind of a simple example is the coin flip situation. So that's your investment, that's your project. Your project is a coin flip, and that one's pretty easy to do because you only have two outcomes, either heads or tails, and you can list the probability of those outcomes here. So right there, that is your basic probability distribution listed right here. Let's make it a little bit more real world and a little bit more complicated. So you have a project of either, let's say, opening up a freestanding MRI center, which they do exist, or opening up a walk-in clinic. And over here, you have your different economic states that are going on throughout the community and your region, anything from very poor to very good. So, where do we get these estimates from? Again, that's maybe historicals where you could find this stuff where it's happened in the past. We do know, for those of you that have been in healthcare for a while, we do have economic states that impact our overall success rates or returns that we have. I mean, when you look at an economic state, if you have a very poor economic state, um, maybe tax revenues are down, employment is down, and employment is down. Well, this particularly hits us here. When we have high unemployment rates, then we have high uninsured individuals. They're still coming in for those scans, getting a five, $10,000 scan, and they have no insurance. When employment's great and everybody's getting a job, then of course you're getting the very good. You in this area you have more people employed, more people having insurance and that coming in there. So those are all kind of things that can impact the economic state of a community or region that can impact, I guess, our decision here with either an MRI center or a walk-in clinic. And then you attach returns to each one of those various economic states. So if we had a very poor economy in the toilet, you're having a high degree of uninsured individuals, um, a very competitive situation where you're scrapping for every scan you can get, you're going to lose, you're projecting to have a loss on this particular project of 10%. And same thing with the clinic. So take a look at these numbers here. Here's another little thought question. Take a look at these numbers. Here are the probabilities of these events. Let's talk about that too. The probabilities are listed in decimal format. Probabilities are percentages also, so either way. Sometimes for math it works a little bit easier with the decimals, but you can also deal with percentages. So what this says right here, that the chance of occurrence of a very poor economy is 10%. The chance of a poor economy is 20, average is 40%, and so on. So I think you got that. And the decimal point is just expressed in this fashion. Whenever you add up, and here's other a key point for you. Whenever you add up the total possibilities, these total outcomes that we have here, whatever they are for whatever probability distribution that you're doing, they always have to add up to 1. because you always have to have, at least when you add up all the different possibilities, uh, one of them is going to trigger. So it's always one of them for sure is going to happen, and that for sure is 100%. So you always have to add these up, check your math, and make sure that you equal 100% or 1. And these again are just the rates of return associated in again a percentage format. Okay, so there is what we look at as far as a distribution of those possible outcomes. Now, let's take a look at something called expected rate of return. Now, don't freak out. This isn't as hard as what it looks like. But really, what the expected rate of return is, it's just a weighted average of those returns that you have listed in your going back up here in your probability distribution. And you're going to be taking these two numbers and multiplying them together and adding them up. It's not that difficult. Let's take a look, just refresh your memory here. Take a look at these numbers here. The negative 10% return, the zero, break even, you didn't make anything, the 10%, so on, okay? And then the probabilities assigned with that. If you don't know how to do a weighted average, again, it's pretty easy. This only takes basic calculators. So the expected return on the MRI is we're just simply going to take the probability of the event, and in this case it was that poor economy that was in the toilet, was 10%, so we'll leave that in decimal form. The return on that was 10%. So simply run your math on that, and you should get a -1. And then well, let's work them all together. So that's a -1 right there with the order of operations. So we always want to do this little area first. Now let's move on to our next one. That one I don't even need to whip out the calculator for, because if you have a 0 and you're multiplying times anything, it's going to be 0. So we'll just move on from there. And then we'll simply take, whipping out my calculator here, we're going to take the 0.4, that was the probability assigned for, I think, the kind of average economy, times the return, which is 10%. So 0.4 times 10, for those of you that are good with math, probably already figured this out. 0.4 times 10 equals a 4. Okay, so we got a -1, we got a 4. Let's go on and do that for our next one. 0.2 times, and hopefully you're following along with me. Get your calculator out, follow along with me. We're going to have another 4. And for our last one, let's see here. For our last one, and I just had to check that quickly. For our last one, that's actually not a -30. This is the really great economy. So let me correct that right there. Is 30. And we've attached a probability of that happening of 10% or 0.1. And that equals 3. So we add them all up together, a -1, a 0, a 4. These are the weighted averages, a 4 and a 3. And that is where we get our total of 10 or 10%. So the expected rate of return on that MRI clinic or standalone MRI center is 10% when you take all the different probabilities. Let's just go up here real quick and take a look at those. You take all these together and simply multiply this times this, come up with a number. This times this, come up with a number. Add those numbers up, making sure you have the ones that are negative, you keep them negative. And in this case, our expected rate of return on the MRI center is 10%. Might be a little bit more, might be a little bit less, but we can at least say we expect to get 10% on this based on the various probability distributions that we've calculated. Now, what I'd like you to do is pause the video and go back and take a look at the clinic. I want you to calculate the expected rate of return for the clinic. I'll leave this up here. and then jump back and we'll do an answer reveal on that. Okay, did you pause the video and try it yourself on the clinic? All right, well, let's do our answer reveal on that. I'll bring in the answers. Here they come in from the side. There they are. Okay, so what I basically have done, just as a refresher, um, all you want to do is multiply. You're doing that weighted average, so you're multiplying the probability of the occurrence in your distribution table here. You're multiplying that times the anticipated return for that particular event. So I've got two. These should all be percentages, by the way. Sorry. So I'll put a, now there we go. Let's just make this look right. There we go. 2%. On this one, 0, because anything times a 0 is a 0. 0. 0.4 times 15 is 6.2, or 20% chance of happening for a 30% return equals 6. A 0.10 for 50. Again, a percent of return on that equals 5. Add them all up. That's all you got to do. So the expected rate of return on this clinic is 15%. So which one would you do? I don't know. I think I would do the clinic. If you look at it, if I have a poor economy, I'm losing no matter what, and I'm only losing 10% more, um, for that one chance of that. So I would probably go with the clinic and not do the MRI machine. But that's me. Remember, am I a little bit more risk adverse or a little bit, willing to take on a little bit more risk? It's kind of that individual profile. Some companies will have certain expectations already hardwired into what you're allowed to do or not allowed to do. But in this case, I think I'd probably do the clinic. Now let's just wind up our discussion here with talking about that expected rate of return and really what that is. And it's important to remember that that is your best guesstimate, or estimate really, before the investment is made. You're really just playing with theoreticals at this point. You're attaching those probabilities to various events. You're making your distribution table, but it's really before an investment is made. Now, when the rubber hits the road and reality hits you in the face, and it's really after the fact, and you actually a real return is measured, that is called the realized rate of return. So that's kind of the real world. Interesting to see, how would you compare with your expected rate of return versus your realized rate of return, and realize that they're rarely equal. Getting it right is very difficult to do because of this thing that's always present in anything that we do called risk.